All right, so today we're going to talk about the mean absolute deviation. Basically, all what the mean absolute deviation does is it measures, it's a measure that gives the average distance of each data value to the mean. So our steps in order to find the absolute deviation is we have to find the mean first, and then we find the distance of each value from the mean, and then we average those distances. So for example 1, we want to find the mean absolute deviation of data sets A and B and round to the nearest tenth if necessary. So to begin with, I need to find out what the mean is. So remember from yesterday, we found the mean by adding up all of the numbers. And dividing by the total number. So divide by 5. And we get 8. So then I have to find the distance from 8 to each of these data values. So I'll take 8 minus 1, 8 minus 3, 8 minus 5, 8 minus 14, should be 6, and 17 minus 8. I just want the distance. Remember, distances cannot be negative, so that's why I used positive. So once I flipped, I took 14 minus 8 to get the 6 and 17 minus 8 to get the 9. And I'm going to divide by 5. This will be 30 divided by 5, which is 6. So this is my mean, and this is the mean absolute deviation. So for data set B, I'm going to find the mean first. So I'll take 5 plus 6 plus 8 plus 9 plus 12, divide it by 5, because there's 5 numbers. That gives me 8. And then I'm going to find the distance. So 8 minus 5, 8 minus 6, 8 minus 8, 9 minus 8, 12 minus 8, and then find that average. So I'll add all those together and divide by 5. So this gives me 10 divided by 5, which is 2. So my mean is 8, and 2 is my mean absolute deviation. So the closer the mean absolute deviation is to 0, the less variation there is in the data, and data values are clustered around the mean. So how do outliers affect the mean absolute deviation? Basically, they raise it. So we want to find the mean absolute deviation of each data set and round answers to the nearest tenth if necessary. So for example 2, we have the speed in miles per hour of Will's last 6 pitches. 71, 78, 75, 74, 80, and 72. So I'm going to start by finding the mean. So I add those up. 71 plus 78 plus 75 plus 74 plus 80 plus 72. Divide that by 6. So that would be 450 divided by 6, which is 75. And then to find the mean absolute value deviation, or the mean absolute deviation, sorry, I'm going to take 75 minus 71, 78 minus 75, 75 minus 75, 75 minus 74, 80 minus 75, and 75 minus 72. And then divide this by 6. So I add those. That gives me 16 divided by 6. Let's see here, I had to round to the nearest tenth. So 16 divided by 6 is 2.7. Next, we'll do the same for Nora's science grades. So first I have to find the mean. So I'll take 100 plus 52 plus 80 plus 96 plus 90 plus 74 plus 86 plus 94 and divide that by 8. So I get 672 divided by 8 is 84. And then to find my mean absolute deviation, I have to find the differences. So I'll take 100 minus 84, and then 84 minus 52, and then 84 minus 80, 96 minus 84, 90 minus 84, 84 minus 74, 86 minus 84, and 94 minus 84. So find that average, so I'll add all those up and divide by 8, and I get 92 divided by 8, which would be 11.5. So notice we had this outlier of 52 in here, so that's what made this so much higher. I mean, the closer it is to 0, we know the closer everything is bunched together. And that's it for today for our notes, so you can use the rest of the hour to work on homework.